All right, what's up, Math 8? Today we start chapter 4, which is with 4.1, where we're going to look at representing relationships. We're going to be looking at a lot of graphs, tables, equations, things like that. So yeah, let's go ahead and get right into it. One thing, linear equation, they've got it as a recall here. Hopefully we know what linear equation is, right? It just means that the graph of it is going to be a straight line, and that is in the word linear. All right, so we've talked about that quite a bit. So hopefully you still remember that. If not, you might want to write it down because it's very important. All right. So just remember, linear means line. Okay. And we'll just hop right into examples. So example 1. It's looking at the number of liters in quarts. All right. So number 1 says, write an equation to find the number of liters in any number of quarts. Describe the relationship in words. All right. So this is another one, or this one is kind of like what we were doing at the beginning of the last chapter, where we're just looking at the relationship, seeing the rate of change. All right, we can see here the rate of change is 0.95, while the quarts change goes up by 1 each time. All right, so and they have it written right here for you. There's 0.95 liters in every quart. All right, that's basically, I should underline that. That makes it look like it's two different things. But no, it's 0.95 liters in every quart. All right. And yeah, that's just something we kind of saw a lot during last chapter. So hopefully we still remember that. And we'll just go ahead and move straight on to example 2. So using that information, and I forgot this equation. So they gave you the equation L equals 0.95 Q to represent that. So L is liters, Q is quarts. All right. So for every liter, there are 0.95, for every quart, there are 0.95 liters. All right. If you look at number 2, how many liters are in 8 quarts? All right. It tells you that Q is 8 when it says 8 quarts. So we're going to take the same equation. Instead of putting Q, we're just going to plug in 8 for Q. All right, and then that'll give you your answer, which they say is 7.6. I'm going to go ahead and trust them on that. So yeah, that's really all you have to do for that one. Again, pretty much just review there. Nothing new, nothing special. So yeah, we're going to go ahead and move on. I'm not going to have you worry about doing the got it problems, just because this is what we've done all chapter long. So we'll go ahead and move on now. All right, example 3. They're looking at a real-world problem where it says total distance Marlin ran in 1 week is shown in the graph. All right, it asks us to find an equation to find the number of miles ran y after any number of days x. All right, so they use the slope formula, which is fine. If you don't remember the slope formula, there it is. That's a good thing to know how to do. All right, to use the slope formula, okay? But we used it all chapter, so I'm not going to worry about it too much again. And I'm going to look just at your rise over run to find this. So if we start at one point right here, the 3.5, I'm going to go up. That is 3, okay, because that's halfway between 6 and 8 is 7. We're starting at 4, so 7 minus 4. That would be 3. All right, and then our run is going to be 1. Our rise is 3. Our run is 1. Our rise is 3. Our run is 1, all the way up. Okay, remember, that is not how that line looks because this is a linear equation. Okay, since it's linear, it's a straight line, a single straight line. That's just representing our rise over run change. Okay, so don't think that that's the actual line. This is the line that we need. Okay, which is a slope of rise was 3.5, not 3. Sorry, I think I said 3 earlier as well. the rise is 3.5, okay, and then your run is just 1. So we have 3.5 over 1, which equals 3.5. All right. So there's our slope, which is the letter M. Okay. And then we're going to write our equation in slope-intercept form. So now we need to see what our y-intercept is. We can see by our line, it crosses the y-intercept at 0 right there. Okay. So b equals 0. Remember, b is y-intercept in the equation y equals mx plus b. Okay, so now we just need to plug in. Remember, y and x stay the same, so we're going to be left with y equals our slope, which is 3.5 times x plus our b, which is 0, so plus 0. And then that is the exact same thing as y equals 3.5x if you just want to leave it without the plus 0. All right. So yeah, that's really it for example 3. Hopefully we remember that as well. And then if we look at example 4, we're now going to use this equation that we just found to find out how many miles he's run after 2 weeks. All right, so 2 weeks equals 14 days. Okay, because there's 7 days in a week. Hopefully you're aware of why 2 weeks is the same as 14 days. All right, and they're talking about the number of days he's run. Okay, so now we can plug in 14 days for x. So we'll have y equals 3.5 times 14. All right, and then we can just plug or simplify that. So 3.5 times 14 equals 49. So that means after 2 weeks, he will have run 49 miles. Okay. All right, so I do want you to go ahead and do got it problems C and D, just to refresh your mind a little bit. Again, this isn't anything new, but I know it was a little bit more challenging than some of the other stuff that we covered in the last chapter. So I want to make sure that we are good to go on this before we move on. So go ahead and do that real quick. All right, and then the last bit that we're kind of looking at here, we're looking at this example 5 on page 271 at the top. It says Chloe competes in jump rope competitions. Her average rate is 225 jumps per minute. All right. It asks us to find an equation to find, or write an equation to find the number of jumps in any number of minutes. All right. So minutes, that's going to be our x. All right, because that's the independent variable. And then the number of jumps will be our y, because it's depending on the number of minutes. So it's the dependent variable. All right. So we can write that then as y equals 225 times x if we put it in our standard, or not our standard form, in our slope-intercept form, because we would have plus 0, right? Because she doesn't start with jumps at 0 minutes, right? Her first jump is after the time starts. All right. So our equation is y equals 225x. All right. They put j equals 225m. That's fine as well. It doesn't matter which one you use. I just prefer to use y and x most of the time, but if you want to use j and m, that's fine as well. All right. So just remember y is j and x is m for this particular example. All right. So we've got our equation. Then number 6 says make a table to find the number of jumps 1, 2, 3, 4 in 1, 2, 3, 4, or 5 minutes. Then graph the ordered pairs. So they went ahead and did that. I'm not going to take the time to do it. I'm just going to show you here. So they have the table here. All right. Typically, I'm just going to do x and y. Right. So I would just do x and y. And then it'd be 1 minute is 225. 2 minutes is 450. 3 minutes is 675, and so on. All right. They went ahead and put this middle column here. All right. That's just telling you what to plug in for m, or in our case for x. But it tells you also right here what you're plugging in. So it's not entirely necessary, but if you like it being there, if it helps you visualize it, that's another good way to do it. But so I actually did show you the table right here for our example. They've also got it shown in your book right here. So whichever one you want to look at. And then to graph it, again, you just do your x on the bottom. So after 1 minute, it's right here, and up to 225 right here. All right. So this is the graph for this table. Okay. They both represent the same data. Okay. That's the main thing for what they're trying to tell you on this example, is that they represent the same data, even though they're two different means of representing it. Okay. So I do want you to go ahead and do got it problems E and F on your own, just to make sure we're good on graphs and good on tables as well. So go ahead and do that. And then after you've finished that, we are actually going to be done for this video lesson. So hopefully we're all good on everything. If you have questions, make sure you write them down, make sure you ask them, and then we'll go through it, and I will see you guys in class.